Let's take a moment to look at some of the terms that we should know regarding endpoint security. First off, a host-based firewall. It's pretty common for your operating system to have a built-in firewall. Now, that could be built into your operating system, of course, and sometimes we'll enhance it with a third-party firewall that still runs on the endpoint. And the goal of that, of course, is to look at incoming and outbound connections, and we can, of course, limit those. So instead of just allowing anything to come in or anything to go out, we can create a policy, many times from a central management console, and then push that policy to all of our users, or group our users based on job function or role, and then push out appropriate software firewalls to all of them. Within the host-based firewalls, even using something as simple as the Windows firewall, notice here that we can build both inbound and outbound rules. When we create rules, we can give it a name. We can even put these rules into groups. We can associate them with profiles like private and public. This refers to the network that you're attached to. A public network would be like a university campus or coffee shop, where private might be your home. And the idea is that we can have different defaults for what's appropriate in each environment. Really useful if you have a good understanding of the communication that's used by each of your services or applications. If we like, we can create new rules for the firewall. It's pretty straightforward. We would create a new rule, and then we'll specify what is it that we want to allow, a particular program, perhaps a port. We can come up with things that are predefined as well as custom. The goal with the host-based firewall is to protect that one single host. Sure, there's going to be network firewalls throughout the organization, but the idea is that we can become much more specific here because all the traffic just has to deal with this one individual host. The features that are going to be provided are going to vary by the type of personal firewall that you're using. They're different between the different operating systems in terms of what you can do with capabilities. And then, of course, once we move into third-party solutions, you're going to get even a broader array of offerings in terms of capabilities. Most host-based firewalls are going to monitor both incoming and outgoing connections. This is great because a lot of times you can embed URLs inside of things like Office documents. So if you're editing a spreadsheet and it's trying to retrieve external resources over HTTP or run JavaScript, we might be able to catch that, and we might be able to prevent it really easily, just right there with the software firewall. Most host-based firewalls are going to have a logging feature, and this is going to be real useful anytime we're trying to do any type of troubleshooting after the fact. So if you've got a logging feature, let's try to make sure that it's turned on. And if you've got an ability to set a maximum log size, let's try to set that as well. Some examples of Linux-based firewalls include IP tables, TCP wrappers, uncomplicated firewall, as well as, I'm not sure if anybody uses this, but TCP port knocking. This isn't really appropriate for enterprise. You're not going to have your accountants and and marketing people doing this, but it's pretty slick for IT folks. If you haven't seen it before, let's say that I've got maybe remote desktop or like VNC that's listening as a service on a server that I have. And I know that there's vulnerabilities from time to time in RDP and VNC, so I want to protect it. And I want somebody to first have to authenticate before they get access to the port. So think about it like TCP 3389 for RDP. We're not going to accept a TCP SYN to come in until you do the secret handshake, like a. If you tell it to do that, it's going to be like, hey, connect first by sending a TCP SYN to port 80, and then port 800, and then port 8000. Looks a little weird, but when your system detects an 80, 800, and 8000 SYN, and this is just the number, like a combination lock. You'd pick whatever you want. If we see those SYNs come in within a range, let's say 5 seconds, we go, oh, that must be a trusted user. We modify an entry in our ACL, and we allow incoming connections to hit that particular service. Again, this is a little bit more for the hobbyist or for the true geek, but it's a neat way to hide all your services. We can layer this on top of say TCP port 22 for SSH. So if somebody's doing a sweep of the environment and they're looking for vulnerable services, they're not going to find ours. It's a pretty slick way to hide. And then if we want to get into it, we do the special knock, it goes ahead and allows access, and then we can come right in. Pretty neat. Again, the software firewalls themselves, pretty straightforward. Windows firewalls enabled by default. You probably have encountered it at one time or another where maybe you installed like an FTP server or a little syslog server or something on your system, and you try to have another system talk to it, and you're like, I don't get what's happening. I started the service, but it's not connecting. We always jump into the Windows firewall to do some troubleshooting. A lot of times just turning it off globally in testing, you'll see the connection go through. And then we go, okay, it was definitely our firewall. Let's jump in there and find the specific role. Host-based antivirus is just the concept of scanning files for containing viruses or potentially spyware, and we're doing it locally. Remember that signatures are used within antivirus, and those signatures don't really protect against zero-day attacks. Why? Because it's a definition of a known attack. If we don't know the attack, we obviously can't create a definition for it. That's where devices say, oh, well, we use heuristics, or we're behavior-based. We can see strange things happening. And because they're not relying on a signature, they're relying on actions, anything that's behavior-based would have the capability to detect a zero-day attack. Most modern antivirus is capable of providing some level of real-time protection, but they can also be circumvented pretty easily. We've got guys in our local hacking group that all they do is focus on antivirus, just finding vulnerabilities in antivirus. Pretty crazy. The neat thing is if I can find a flaw in antivirus, I can typically use it for privilege escalation. And a lot of folks don't focus on hardening their AV platform. If you've used Cisco AMP before, I think that's a really solid contender. Some of the other ones out there may actually leave you vulnerable. So you're running antivirus to protect yourself. Somebody gets into your system through some type of operating system flaw, and maybe they're trying to escalate, and they look around, they go, you know what, I don't have any Windows 10 0 days. I don't have any way to escalate to get root privileges or admin type privileges or system privileges on a Windows box, but look, they installed an antivirus. And if your antivirus is vulnerable, this could actually be the vulnerability that the attacker leverages against you to get control of your system, actually using your own security tools against you. It's not that uncommon. So the prevalence of spyware led to the development of anti-spyware applications. And what you'll see from a lot of security vendors is that they've got products that cover a lot of different solutions. They do a little bit of all of these. Host-based IPS, right? We've got network-based IPS, which is looking at packets go across the wire, but easily defeated through encoding, easily defeated with encryption, easily defeated through fragmentation. Your network IPS isn't decoding and decrypting and reassembling everything. It's capable of it, but not everything all at once if you've got a lot of traffic. It's typically some subset of the features that we can use depending on how much box we bought. So we know that traffic that's hostile can potentially sneak by our network-based IPS. That's why the host-based IPS is the kind of like the other half of the solution. This lets us see anything that crept across the network and made it into the system. You can fragment, you can encode, you can do whatever you want, but once it's reassembled and it tries to take action, the host-based IPS is where we're going to be able to capture the attack. And they'll typically leverage kind of a mix of different techniques. Signature-based, going, these are known attacks that we've seen before. Anomaly-based, going, that looks strange. Why is Internet Explorer trying to write to the Windows System 32 directory? Again, it can be policy-based. We can just look for things that should exist or not exist within an environment. And really, a modern solution uses a combination of all of these. When we hear the term application whitelisting and blacklisting, these are kind of opposite approaches to doing the same thing. We want to make the environment more secure. We want to allow only certain applications to run. And you go, well, which applications? You see a blacklist allows everything to run, except for things in the blacklist. Whitelist allows nothing to run except for things in the whitelist, which is great. That's going to be super secure, but you're probably going to be interacting with the users a whole lot. You're going to be making lots of exceptions, at least during the initial learning curve. So application whitelisting within the Windows operating system, we can do this through Group Policy Editor. And of course, you can do this with third-party tools. We can say we want to allow certain applications, not allow certain applications. And when we build these policies, we'll, of course, assign them to groups. We put users into the groups. and then these policies would be deployed across the organization. So when we look at host-based malware protection, we make some assumptions, right? Antivirus, anti-spyware, they provide a line of defense, but they're not always very effective. Depends who the vendor is. Some have a better reputation than others. You must assume at some point malware is going to make its way into the network, and when it does, what's it going to do? Are we going to detect it? How long is it going to take? How much damage is going to occur? We can't be impenetrable. Guess we'd all be out of work if that was the case. But what we can do is tune it the best we can, and we can kind of try to limit what happens when that inevitable breach occurs. So the endpoints need to be protected before, during, and after the attacks. You can all appreciate that. And when we leverage Cisco AMP, this is an advanced malware analysis platform and protection solution, right? So it's doing the traditional things. It's using signatures. It's using heuristics, but it also has got the ability to leverage a sandbox and get some really good insight into what applications are actually doing. So when we look at AMP for endpoints, its architecture is fairly scalable, right? We've got a cloud solution that we can use for managing all of our policies, deploying updates to users, and then of course there's an endpoint that's available for both mobile and traditional computers. Once we put AMP on that endpoint, it gives us cloud-based detection of malware. We've got a connection to Cisco, so we're constantly getting new updates for threats. We're getting rapid detection of known malware by just looking at a file's hash. We look at the hash of the file, we look at a list of known bad hashes, and we know right off the bat if something's bad. For things that have a hash that we haven't seen before, we can punt them to the cloud, analyze them in a sandbox, and come back and make sure that that file is actually safe. Additionally, we have a historical perspective. So we can look at who the first person infected was, when they were infected, what other files that particular file that was malicious tried to touch, and follow what they call the trajectory of the attack. So if you haven't heard the term sandboxing before, this is kind of neat. It's just dropping a piece of software into a dedicated, hardened environment. We're going to run that file, and we're going to analyze the behavior. Now, some of these sandboxes are pretty fast. They'll do things like change the date forwards to catch things like logic bombs. A lot of times you'll have an application, and the application's not going to go off and do something nefarious until 90 days or until 180 days. And the attacker keeps resetting that counter, and he figures, or she, figures that, hey, if I'm not here anymore and I don't move this counter forwards, everything's going to blow up without me. Well, by using a sandbox, by auditing the code, by changing the time and kind of running it faster than normal, we can watch the way that it behaves. Now, of course, this isn't a super secret technology. Attackers know that there's sandboxes out there, and good malware is going to try to detect a sandbox and protect itself from it. Cisco has a sandbox that they can tie into your security solution, and this is referred to as Cisco Threat Grid. So Threat Grid's integrated across many of the different security products. AMP, of course, which is what we're discussing at the moment, but we've also got hooks into Firepower, into the ESA, into the WSA, as well as IPS. Whenever we see files that look suspicious, new files that we've never seen before, we can punt them to the cloud where they can use lots of resources, intelligence to audit that file and bring us back a report. So this is just an example of the Threat Grid console. We can see that it has a modern interface. We can see the behavioral indicators. We can see the description of an HTTP request here that's potentially doing something malicious. Below at the bottom there, you've got the decoder of the HTTP header, and we can look at the various fields. Really, really nice interface. Another way that we verify the integrity of files is just through integrity checks. This comes back to basic hashing. Just wanted to stress that file integrity checks are just kind of like a basic day-to-day task of system administrators. When we're downloading firmware, when we're downloading ISOs, we want to make sure that this data has been modified in some way. Remember that attackers can get in the middle of a download, and they can modify the file while it's being downloaded. Again, if you're using TLS, this is going to help you out quite a bit, but there are also attacks against TLS. There's things like downgrade attacks. So regardless of how we downloaded the file, we want to do everything we can to validate that that hash of that file that you just downloaded is exactly identical to the known good hash for that file. As far as verifying it from the CLI, it's pretty straightforward. There's a verify command, and we can run that against a file, and here you can see the SHA-2 hash that's being generated. We can just look at this hash and verify the hash that we've created against the hash that's stored in the file. If it matches, we know that this file can be trusted.